Welcome back to my channel. Today we're going to be talking about derivative notation, tangent lines, and how we can find them. So before we get started, don't forget to like, subscribe, and hit that notification bell. So the first thing we need to talk about is derivative notation. So these are ways that we can tell that it is either a derivative or we can write to show that our function is the derivative. So given a function y equals f of x, the derivative of y equals f of x can be written as. We have a couple different ways we can do this. One of the most common looks like this. It looks like it has like an apostrophe on it. This is f prime of x. So anytime we see that apostrophe, even when we were in geometry, something that moved, something that changed, f prime of x is our signal for a derivative. Just like that, we could also say y prime. So y equals f prime of x, so y prime is also something that we can go with. With y specifically, we don't actually have to write y prime of x or y of x because it's just assumed. Our last way is completely different, but it's something that we'll use in very specific situations, and you realistically can use it whenever you want, and that is df over dx. And that just means the derivative of our function f with respect to x. We're going to be using this one a lot, especially if we change what function we're using or if we're changing what thing we're taking something with respect to. And we can kind of interchange independent and dependent variables as we need. So one of the things that you need to know is what kind of phrases we see when we take derivatives. So clearly if we have something like the derivative of, we're going to use a derivative. But we need to remind ourselves that derivatives are slope. So when we say slope of something, that means take a derivative. Calculus is the math of change, and one of those kinds of change is a rate of change, which is another way to say slope. So if we see the words rate of change, there's a good chance that we need to take a derivative. Our last major way is if we see the words tangent to or make a tangent line. So if we see that word tangent and it's not talking about the trig function tangent, then we are going to probably have to take a derivative. So derivatives as we know them so far. We have the derivative of an equation. So this is f prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x. This is the limit as h approaches 0 of our difference quotient. Something that we need to know about this is that this will give us an equation. This is what we are going to eventually do more often. But if we just need a singular point, that's not going to be that helpful. On the other hand, if we have a lot of points that we need to look at, or like a lot of x values to look at, finding the equation just makes things go a little faster. If we don't need to do much and we just need a derivative at a singular point and nothing else, we may use the derivative at a point. This first one is almost exactly like our difference quotient above, except it is using c instead of x, assuming c is a number that we can plug into our function. On the other hand, this one over here, f of a is equal to the limit as x approaches a of f of x minus f of a divided by x minus a. And this is kind of that slope formula, just written in a slightly different way. So we can kind of look at the derivative of a point in a couple different methods. These ones will give us a specific value. So a number. Okay, so derivatives. A derivative is just the change in something. So the derivative is just slope. So slope, the rate of change, anything to do with changing is a derivative for us. So one of the things that we're going to be doing is writing the equation of a tangent line. So the derivative tells us the slope. I just remembered what was going in the spot. So the derivative is the instantaneous rate of change. That also means slope, but instantaneous rate of change as in the change that's happening at a singular point. So a derivative tells us the slope of the line tangent to the function at a given point. But a big thing that we have to remember is that this is still an equation of a line. Equations of lines are things that we learned how to write a long time ago, but sometimes we forget. So to write an equation of any line, we always need two things. We always need slope and some sort of point. What kind of point is kind of dependent on what kind of equation you want to write, but for the one that we're using, it's going to be any point at all. So in this next video, we're going to talk about specifically how to write the equation of a tangent line and what that would look like overall.